All right. Uh, all right. I guess we can start now. So, just a second. All right. Today's discussion is about lexical semantics, and in today's discussion will be slightly different in the sense that in the initial part we have questions like we have been doing the previous weeks, and those are like MCQ questions which I would also expect your participation. But after that, there are three questions where we will actually explore how to use WordNet in real life. So basically, we will be doing small code snippets that will show you basically how to use WordNet for different uh, solving different questions. So like that involves a bit of Python. So even if you don't know Python that well, that won't be a problem. It's more like executing some functions of the NLTK library. So we will see about that. Let's first start with the main chapter. All right. So as you know, like these are the uh, hypernymy and hyponymy trees, like which denotes which is a hypernym of what, and so on. So the question is based on Resnick similarity. So what is the Resnick similarity between motor vehicle and car? All right. So before you answer the question, I want you to tell me what these values. Do you think what these values signify in the tree or in the figure? So as you can see, there are values.
Information content.
Yes, yes. These values signify the information content because as you can see, there are values greater than 1, so they cannot be probabilities. So thus they are the information content, which is minus log 10 of the probability. Alright, so the information content at every node is given to you, and now you have been asked to find out the Resnick similarity between motors vehicle and car. So would you like to take a guess? You can get this answer directly from the figure. Okay. So, first of all, for Resnick similarity, we need to find the lowest common subsumer, as you know, the LCS, or the lowest point in the graph which is common to both the given words. Alright. So, what is the LCS for motor vehicle and car? Like for these two words, motor vehicle and car, what is the LCS? Not words, concepts. So,
9.53.
yeah, so the answer is actually 9.53, and that is because the Resnick similarity is defined as the information content of the LCS. So, this is the most simplistic formula among all the similarities which you calculate. So you just need to find out which one is the LCS. Now between motor vehicle and car, we need to find out the node which is at the lowest point in the tree and common to both. So obviously in this case that LCS will be motor vehicle because car comes under motor vehicle, and yeah, like they are like car is a child of motor vehicle, you can think. So from that point of view, motor vehicle is the LCS, and thus the Resnick similarity is just the information content of the LCS. Sorry for IP, this should actually be IC. Okay. uh, yeah, so IC of motor vehicle, which is 9.53. All right. So, what is now the next question is from the same tree. What is the Lin similarity between cycle and article? So, how do we calculate Lin similarity? Like, can anybody tell me? Do we use the IC values here or do we use the log values for calculating link similarity?
IC values only.
Yeah, basically IC and the log values are related, but how does the formula
Hmm.
look for calculating link similarity?
IC of LCS upon individual ICs.
Well, you came close but not quite. So the link
Log.
similarity is not defined in terms of the uh, IC actually. It is defined in terms of log P. Obviously, minus of log P is the IC that you know. So you can think of it as minus. So like it is twice of the IC of the LCS divided by the sum of the individual ICs. Okay, like however you do, the minus sign gets cancelled out from both numerator and denominator. So we can write it like twice of IC of LCS divided by sum of the individual ICs. So if we, or we can directly calculate from the formula. So basically log of the probability is minus of the IC. So either way, we have to do that. So first about LCS. So now here we are doing between cycle and artifact. So cycle is over here and artifact is sorry, cycle and article. So cycle is over here and article is over here. So obviously the LCS is artifact because that is the lowest point in the tree which is common to both article and cycle. Okay, because cycle belongs to this left hand side branch, and article is in the right hand side branch. So artifact is the lowest point which is common to both. So the LCS of cycle and article is artifact. Now for calculating the similarity, we just plug it into the formula and we get this answer. Alright, so let's see the next one. This is Gian-Conrad distance. So you have to find out the Gian-Conrad distance between object and cutlery. So object is over here and cutlery is over here. So yeah, what what is the formula for calculating Gian-Conrad distance?
1 upon one upon sum of their ICs minus 2, so 2 IC of 2 into IC of LC.
Now I think you got slightly jumbled up with the previous one. Would somebody else like to try?
I'm saying 1 upon
No, actually for
IC
Gian,
of object plus of IC of,
yeah, go on, go on.
okay, there is log.
Yeah, like don't get confused between the previous one and this one. Here we do not have the numerator denominator parts actually. So basically the Gian-Conrad distance is you add the two individual ICs and subtract twice the IC of the LCS. So here there is no numerator or denominator, it's in plus and minus. So just take care of that because yeah, this formula looks very much similar to the previous formula because we have same kind of terms. But yeah, that was like twice of the IC of LCS divided by the sum of the ICs. Whereas this is sum of the ICs minus twice of the IC of the LCS. Okay, so yeah, like these problems are all about knowing the formula. So if you know the formula, you'll be able to do them. There's not much complexity to it. So yeah, kind of like a bit of mugging up, but all right, you know that these things are also part of the entire syllabus. So yeah, like you just have to remember the formulas and rest of it is straightforward. So LCS of object and cutlery. So object is right at the top. So when it is right at the top, obviously there is nothing below it which can be common to it. So that is why the LCS is object, and the distance we just plug in the values from over here and we come to this. Okay. So these three questions are based on your knowledge of the formula. So if you know the formula, you'll be able to do them. Everything else is kind of given to you already. Okay. So let's go on. So a bit of a theoretical question. So we have six sentences, as you can see. Like statues were cast in clay molds. The Indian caste system is an example of social stratification. My dog would always bark at strangers. The tree's bark has medicinal value. The newspaper was delivered early today, and the newspaper recruited a new investigative journalist. So you see, between the pair of sentences, the words that are marked in bold, those have some lexical similarities between them, right? So we have to find out the relations between each of these pairs. So these are the options. So A is all of them are homonymy. B is homophony, homonymy, polysemy. C is homonymy. Uh, sorry, yeah. And D is also homonymy, homography, and polysemy. So before we get into that, uh, what what are these different terms known as? This is what like you have to basically understand the difference between each of these terms and what they mean. All right. So okay. So what is the relation between one and two? Between CAST caste and CASTE caste? Okay. So because this is a bit unclear, let's have a look at what is actually happening. So homonymy is basically words that have the same form but different unrelated meanings. So same form means they have to have the same spelling and same pronunciation. So two words are having same form if they have the same spelling and same pronunciation. So you don't get to define like distinguish between them either from the spelling or from the pronunciation. So you have to distinguish between them based on their meaning. So homonymy is words that have the same form but different unrelated meanings. Like the meanings have no correlation. Okay. Homophony is words that have same pronunciation but different spellings. So they sound the same but are written differently. And homography is written in the same way but sound differently, like different pronunciations. And finally, polysemy is similar to homonymy in that polysemy is also about words that have the same form but different meanings. But these meanings are not like homonymy. In homonymy, the meanings are completely different. But in polysemy, the meanings have some correlation between them. So they are like a different senses, which are like related meanings. So how do we understand all this? Well, see, let's look at the first example. So this is cast and cast. So they sound the same, but they have a different spelling. So obviously this is easy to understand. 1 and 2 is homophony. The words that have the same pronunciation but have different spellings. Okay, let's look at 3 and 4. Both are bark. They are written the same and pronounced the same, but they have different meanings which are completely different. So, like trees bark and dog barking, they are completely different things, right? So, because they have the same form, which is the same spelling and same pronunciation, so it must be either of homonymy or polysemy. But because the meanings are completely different, so this is homonymy. Okay, and over here this is the newspaper was delivered early today and the newspaper recruited a new investigative journalist. So sentence 5 is talking about the item, which is a newspaper, whereas sentence 6 is talking about the organization, like the news organization, which is the newspaper, which is written as the newspaper. Okay, so as you can understand, these meanings are kind of similar, they are related, but they are different. Okay, so that is why this is an example of polysemy, that is words that have the same form but different senses. Okay, so these are the four main things which you have to understand. So when the pronunciation and spelling is different, like when either of pronunciation or spelling is different, it's easy to identify. So that will either be homophony or homography. So if they have the same spelling, it's homography. If they have the same pronunciation, it's homophony. Now the trick becomes when words have both same spelling and same pronunciation, which is the same form. So in that case, you have to look at what the words mean. So if they mean something completely different, like barking at strangers or like the bark of a tree, then that is homonymy. But when they are talking about essentially the same thing but from different senses or from different perspectives, like the newspaper item versus the newspaper organization, then both are related to kind of the same thing but they have different meanings. So that is why this is an example of polysemy. Okay. So this is all about definitions, but you need to have an idea because they are quite confusing, and often there can be questions from this which are easy to score. So you would not like to miss out on such kind of questions. That is why it's very important to understand the subtle differences between these terms. All right, let's go to the next one. So question 5 is, you have given a sentence. Although the buttons did not look good on the shirt, the dress fit well. So you are given four statements. Which of them are true? So dress subsumes button, shirt is a hyponym of button, dress is a hypernym of shirt, and button is a metonym of shirt. Okay. So again we have some more terms, which is hypo and hypernym and metonym. So, like, does anybody want to guess what are the answers for this one? After that, we'll look into the definitions, of course.
Option C.
Yes, C is correct because, as you can understand, shirt is one kind of dress. So, if you are talking about the concept dress, under that you might have many concepts like shirt, pants, skirts, and so on. So, shirt is one form of dress. That is why shirt is a hypernym of dress. Okay, sorry, shirt is a hyponym and dress is the hypernym. Like the one having the broader meaning is known as hypernym. So dress is a hypernym of shirt. That is fine. Okay, so option
D.
C is definitely correct. What other options are correct?
And option D.
Option D.
Option D.
Yeah. Option D. Yeah. Option D is also correct. Button is a meronym of shirt. So let's have a look at what these mean exactly. So you have two ideas over here. One is the hypernym and hyponym concept. So these are about concepts. So the broader concept, which is less specific, is the hypernym, like dress, and a narrower concept, which is more specific, like the shirt, that is the hyponym. So dress is a hypernym of shirt. That is understood. Now, what about meronym? So there are two terms, meronym and holonym, which are like opposites of each other. So meronym means part of. So like uh, you can think of cars and wheels. So like wheel is a meronym of car because a car is constituted by many things, among which one thing is a wheel. One part is a wheel. So similarly, a shirt is made up of many things, but button is a part of the shirt, right? So that is why button is a meronym for shirt, and shirt is the holonym of button. So you have to understand the difference between this hypernym and hyponym thing versus meronym and holonym. So hypernym and hyponym, they are talking about concept. So like how broad is a concept and how narrow is it? Okay. Whereas melonym and holonym has a much more what can we say? A much more practical implication, as in like which is a part of what. So like that has some physical attribute to it, right? So but hypernym and hyponym is about concept. So there is no physical connection between them. Like the button is a part of the shirt, but definitely shirt is not a part of dress. Shirt is a type of dress. So that is the slight difference between these hyper and hyponym concepts versus meronym and holonym concepts. Okay, fine. Let's look at the next question. So this is saying that you are given a co-occurrence matrix. Okay, and there are these two terms, deep learning and NLP. Now, as you can see, there are a total of 914 instances where deep learning occurs, and in 346 of them it occurs with NLP, and in 568 it occurs without NLP. And similarly, there are a total of 2294 occurrences where situations where deep learning does not occur, and out of them 874 times NLP does occur, and 1420 is like none of them are occurring. Okay. And the totals are written along all the axes. So you need to find out the distance between NLP and deep learning according to the hyperlex algorithm. So can anybody tell me what is the formula for finding the distance according to hyperlex? Like what do we need to calculate first for calculating the distance? Anyone? So we need to calculate two probabilities. What are those two probabilities? Okay, let's go over the formula then. So we need to calculate the probabilities of co-occurrence of one term given that the other term is occurring. So we need to do this both ways. So probability of NLP given deep learning and probability of deep learning given NLP. So we know deep learning occurs in a total of 914 instances, and out of them 346 times NLP occurs with it. So probability of NLP given deep learning is 346 by 940. Similarly, we know that NLP occurs in a total of 1220 instances, and 346 of them is where deep learning occurs along with it. So again, this is 346 by 1220, and the hyperlex distance is calculated as 1 minus the maximum of these two probabilities. So again, this is completely based on the formula, and you need to calculate these two probabilities first, and then you need to do 1 minus max of the, and in this case that is coming to 0.621. Okay, all right, so we are more or less done with the questions part. After this we'll show you how to use wordnet uh, for solving some simple questions. So from whatever I've discussed so far, uh, nothing is too complex. All you need to do is remember the formulas. So overall this chapter is about knowing the formulas. So if you know the formulas, you will be able to solve each of them. Like it's not very tricky or not too much of calculations. All right, it's all about knowing the formulas. Okay, fine. Let's proceed towards the NLTK portions. All right. So this is saying that you have to use the NLTK corpus reader wordnet, and a link is given as to how to use. I'll go over it slowly. So the question is, what is the lowest common hypername? So as you know, wordnet gives this. Wordnet has this like the graphs we were showing the figure. So wordnet also has a inbuilt graph inside which captures the relations hypernymy and hyponymy relations between concepts. Okay, so they are asking what is the lowest common hypernym between the first sense of man and the second sense of whale. So like each concept can have multiple senses, right? So for the word man, we have to take the first sense, and for the word whale we have to take the second sense, and then we have to find the lowest common hypernym between those two, and also what is the distance from the root. All right, so we'll look at how to find these out exactly. So before that, let's see. So this is the link which is given over here. So you have to use the link to understand the coding. uh, yeah, so first of all you have to install the NLTK package in Python, and after installing you can import wordnet from NLTK using this command. So from nltk.corpus import wordnet as w1, and then there are two functions. So one function is synsets. So if you give synsets and then you put in a word, so you can see this, I guess, or should I enlarge it? I guess now it is visible. So if you look at this part, so synsets command that returns all the senses for the given concept or word. Okay. So as you can see, they have put in synset of dog, and you are getting all these. So all of them have some relation with dog. And then there is this command which is synset. But for using the synset command, you have to specify the sense. So N stands for noun and 01 refers to the first sense. Similarly, 02 would refer to the second sense. Alright. And each of these senses have a name and a definition. That is how this synset object is defined. So it has a name which is basically this dog.n.01, that kind of thing. And the definition is actually like the meaning of that sense. All right. So if you do, uh, okay, so that much is enough for this question. So now let's look at the question once again. So the question says, lowest common hypernym between the first sense of man and second sense of whale. Okay, and the solution looks like this. So I'll actually work it out and show you how this is coming. So I hope you know. So this is like a Python script. So you can write this like a Python script and you can execute it in a .py file. But here for showing you, I am going to use IPython so that you can understand. Like what I'm typing, that part is visible.
Yes.
Yes.
Okay. So firstly we do this thing. So from nltk.corpus import wordnet as wn. So we have taken the corpus. Now we want to find the synsets for the two words. So what words do we have here? Man and whale. First sense of man, second sense of whale. So as I said, we have the synset command which returns you the sense for that exact the sense number which you say, like first or second or third, like that, and you have to specify it in that format. So the way we do it, let's say man is the concept. So we do man dot n dot 01. Okay, this is same like if I print out man, you can see that it is showing this synset, right? This is same as doing something like using the other command which is wn.synsets. So if you use synsets and you just say man, and we want the first one, so 0th item, so it returns a list of all the senses, right, as we saw in the documentation. So if we give 0, we get the first sense, and if you look at man, it is referring to the same thing. So this is how we can get the particular sense of the word we want. We can either use the synset command, and we have to put it in this form. We have to mention the sense we are looking for, or we can use the synsets command to get all the senses, and then we can use the identifier, like we can use an index to get the sense we want. So indices are marked from 0 to n minus 1. That is why the first sense is at index 0 and so on. So we got the synset for man. Now let's look at whale. So whale, we can do it in the same way. Here we are looking for the second sense. That is why n.02. And we get the synset for whale. Right. Now over here, we have to find the lowest common hypernym. So there is this function lowest common hypernyms. If you just invoke that, you will get this. Okay. So let's see what we get when we invoke that command. So man dot lowest common hypernyms whale. So this returns a list. Okay. Because here we have only one sense each for each word. So the lowest common hypernym will be a single thing. But if they had multiple senses, then this list could have been longer. Okay. So that is why you have to take the zeroth element to get the lowest common hypernym actually. So when we take the zeroth element, we get the lowest common hypernym. So this one is organism.n.01. As you can see, we have an option organism.n.01. So just by that, you can get the answer. But there is also a second part, which is the distance from the root. Okay. So the distance from the root is defined using this command, which is max depth. So that defines the depth of the current node from the root. Now what is current node in this case? So we are finding out the lowest common hypernym, right? And we want to find out the distance of that hypernym from the root. So as in the previous command, so let lowest common hypernym is man dot lowest common hypernyms whale 0. So this is the lowest common hypernym, and to get the distance from the root, we have to do LCH dot max depth. Okay, so you get the answer 5. So as you can see here, that is exactly what has been done, but I am showing it to you in a more detailed way. So yeah, the idea is that these are different functions which you have to use. These are all library functions. So you will get more details of that from the documentation itself. But here I'm just going to show you a few examples of how to find out these things actually. Okay. So this is how you get the lowest common hypernym and the depth from the root. Fine. Now we will look at how to find some similarities. So there are these two words, firm and institution, and they have asked you to find out the Leacock Chodrow and Wu Palmer distances between the first senses of each of these words. So as you know, both of these are similarity measures, and they can also be calculated using the NLTK package. So how is that? So this is even simpler. So as we did before, we want to find out the first sense of the word firm. So we just write this down. Firm wn dot synsets firm, and we take the first sense. Similarly, we do it for institution. So institution is wn dot synsets institution, and we take the first sense again. So this is how we are getting the first and the first sense of institution and first sense of firm. All right. And then what you need to do is you have to calculate these similarities, and those can be done directly using some uh, using some functions which are given by NLTK. So what are the functions here? So one is LCH similarity and the other is WUP similarity for Leacock Chodro and Wu Palmer respectively. Okay, and like the previous one, there how we had called these functions. So you take one object, and like the function is a member of that object, so you can object one dot function and you pass object to as a parameter. So even in the previous one we had done that. So man dot lowest common hypernames well. So similarly, the way the functions are used are similar. So we can do that. So firstly, we want to find out the Leacock Chodro. So firm dot LCH similarity with institution. So this takes a bit of time to calculate. But as you can see, we get the answer 2.208. So if you just look at the options, you will know this is correct. But let's do the other one also. So then you do firm.wup similarity with again institution, and you get the answer. Like this is executed faster. So 0.714. So that was our options over here, and yeah. So this is how we get these values. All right. Let's have a look into the final question. So here we have to do some word sense disambiguation. WSD, you know. So how to do word sense disambiguation? Well, let's have a quick look into the documentation. Like they have a separate documentation for word sense disambiguation. So that is done using the LESC algorithm, as you know. So the idea is in LESC you can send in an entire sentence and you compare that with a particular concept. Okay. So, for example, here they have given this example. I went to the bank to deposit money, and then they have passed this sentence and the word bank to this, and then they get this synset. Okay. Now, the idea is that you need to find out all the synsets for the concept which is given in question for word sense disambiguation. So, if you just print wn.synsets, so as we have used this function in the previous examples also, we have seen that synsets command returns all the senses of the word, and for each sense you can use uh, dot definition to print the actual definition of that sense, and you can use the object direct the variable directly, or you can give like ss dot name to give the name, which is like these things bank dot n dot 01. We have seen in our case man dot n dot 01 and so on. So those are the names, and the definitions are like the actual meanings of those senses. Fine. And okay, so let's see how to use this then. So the question asks, what are the definitions corresponding to senses of the word solution as per the LESC algorithm? So here are two sentences given which contain the word solution, and we have to use this wordnet disambiguation technique to using the LESC algorithm to find out the most probable sense of solution which matches with the sentences. All right. So how do we do that exactly? Well, the first part remains as it is, and for the second part, we import LESC. Okay, so that we have to import the LESC algorithm. So from NLTK dot WSD import LESC. Now, what does LESC do? So let's see what LESC does first. Okay, so if we give LESC and then we give the string heat the solution to 75 degrees Celsius. So we have given the sentence. We need to split it into a list of tokens. So we use the split command of Python. Okay. And that we are going to compare with the word solution. Right. So if we do this, it is saying that the second sense of the word solution is most likely to be the meaning which is applicable in this sentence. Okay. Now, what is this second sense of solution? So, we need to first find out all the senses and their definitions. Only then we can compare with the four statements given over here. Like these are the definitions of the word solution, different senses of the word solution. These are the different definitions. So to find out which definition suits the particular sentence, we first need to find out the mapping between the definition and the names, or like which sense is which definition. So what do I mean by all this? So let's just look at that. So as you know, the synsets command that actually prints out like that returns a list of all the senses, right? So all the senses means we can loop over them and we can print them like this. So this was there even in the wordnet documentation. This is how you do. So if we do this, can you see that we are getting these things? Okay, so let's just do this for sake of clarity because it might be a bit jumbled up. So solution, the first item is solution dot n dot 01, and that has this definition: a homogeneous mixture of two or more substances, frequently but not necessarily a liquid solution. So you can see that is there as one option over here. Then these are the other four senses of the word solution, and like there are four of them have been listed over here, and you need to compare with the given two sentences. So let's go back to what we got previously. So if we do this, we get solution n.02. So what is n.02? N.02 is this one. A statement that solves a problem or explains how to solve the problem.
मेडिसिन भी खाओगे क्या?
ये तो खाया ना, रात को खाएंगे।
So that is number 2. So now you might get a bit confused thinking that for this sentence, ideally we should be having option 3, right? Like here the solution refers to some kind of liquid mixture or something like that. But obviously this algorithm is not perfect, so that is why it can come up with errors. So here for example, Lesk is saying the word solution means this one, part 2, sorry, statement 2, which is a statement that solves a problem or explains how to solve the problem. Now if you look at the other one, she provided a brilliant solution to the long standing problem. So this solution actually looks more to be related to this statement 2, right? So let's check that one as well. So here we change the sentence. She provided a brilliant solution to the long standing problem. So this one is also saying 2, sense 2. So sense 2 means again this one, this. So that over here is option 2. So thus for both the sentences, Lesk is predicting that this statement 2 is most relatable. So that is why the correct answer is 2 and 2. Okay. Alright. So I have come to the end of my part in this session. So if you have any doubts, we can address them now. That can be.
Yeah, Sonak. Few things. So first of all, this word ambiguation that we're talking about right now. So here examples that you have shown are they're asking us to use the NLTK corpus reader. So
Yeah.
we have the old word net with us. Now let's say I believe the questions that we have got in the assignment, or even the questions that may come in your final exams and stuff, will they be asking us to do something like this, or they will be giving us a kind of a tree that has been like in the assignments?
Uh,
And if they ask us to use the word net, so just wondering if this code snippets, we will have to, would you be providing any kind of code snippets as part of solution, or we will have to, be ready with all of this code that you have just now shown
no,
us?
no. So, like these snippets are already there as part of the slides. So when I'll upload the slides, you will get these parts. Now,
Okay.
as far as your exam is concerned, over there, I don't think they will ask you. But for
Mhm.
the exercise, you can have a question or two where you are asked to do these things. And actually, like I have taken this question from last year's exercises, and over
Mhm.
there they have given the link also. So the idea is you can look at this and do, but
Mhm.
just for short, the main thing is that we are not covering a lot of things over here. Like the basic
Mhm.
idea is firstly the use of this synsets and synset command that
Mhm.
gives you the different senses of a word. And
Yeah.
then, like for here, like in this case we have just had to understand these few
Mhm.
functions like lch similarity and then
Yeah.
less over here.
So.
Now as you said, more likely that you will be getting questions where a part of the net is given to you and then you have to find out some values, like we did
Okay.
in the first part of the chapter where we were
Okay.
solving with a tree.
Yeah. Yeah. Okay.
So,
Okay.
like the questions then are in this form, like you are given a tree and then you have to find out some kind of similarity between two nodes or something.
Mhm. Yeah. Yeah. Fine.
Okay.
Okay.
So this is actually giving you a hands-on idea of how WordNet works and all. Uh, just that much. But I don't think this will be part of your examinations per se. Yeah, like exercises, there might be one or two questions.
Mhm.
So I'm not sure
So
about that.
yeah, so I have few questions. I mean, they may not be very specific to the lectures that we had just now,
Hmm.
but I was, let's say, was thinking about maybe if we are going, if the lectures are going to come, then maybe you can take the questions later on. But I just wanted to put the question there for you. Uh, so let's say I have a problem of a classification task. I have a classification task, right? A test classification kind of a thing,
Okay,
and
just 1 second. Before going into that, I just wanted to ask: does anybody have any doubt from this specific part which I covered today? Else, I'll go into Abhishek's question.
I have one question from assignment currently going on.
Like which assignment is it? This week 8 assignment.
This week assignment, released assignment.
So, like, what is your question? Could you just go over it briefly?
Actually, there is a tree of light tree in color and lamps,
Hmm.
and I have to find a score. Not this file. I am talking about the assignment released. The assignment we have to solve. Weekly assignments.
Yeah, actually, that is the point that you should be taking the ideas from these things and solving that yourself. So, like, are you talking about a
So
tree like
actually,
this?
I'm only asking the doubt that what is I have to find a score of between two in the tree between two items, I should say,
Hmm.
color and it's a color and white. So how can I find a score? What is the formula for that? And what is the concept for that? I'm not getting the concept.
So, has it been mentioned just as score or like any particular type of score?
No, it's only mentioned score,
Okay, I'll
and
just.
it's mentioned that distance between two words has the path length between them.
So,
We have to take distance.
okay, okay. Wait, I'm showing you once. Just give me a second. Yeah, so there is one score which can be calculated like this. Okay, so
Okay, so
similarity
I
of the
have to.
path. Okay,
Okay.
Like this is the
Okay.
only metric which does not have a specific name per se. Like the others have some names, right? Like
Yeah,
GL
right.
Conrad distance and so on. So
Mhm.
yeah, so between two concepts you calculate it as like 1 by 1 plus path length between them. Okay.
Okay. Thank you.
So I think that is the score, because all other kind of scores have some particular name, like Leacock Chodro, and then we have things like Resnick and so on, lean similarity and so on. So when nothing has been mentioned, probably they are referring to this score. Okay. So
Okay.
yeah, 1 by 1 plus path length between the two nodes.
Okay.
All right.
Thank you.
All right. So anybody else, any questions from like directly from whatever we have talked about? Okay then. Oh, okay. Abhishek, you can go on with your question.
Yeah. So no, my question was that let's say we have some classification problems to be solved.
Hmm.
So we have little kind of few ML algorithms that we generally use, and if you see most famous of them, something like a logistic regression or a knife bayes and
Hmm.
decision tree, something like that.
Hmm.
So what problems I face? I just wanted to understand how will this word net kind of a thing or disambiguation, how effective would it be to help me get more better classifications, in the sense if I try to, let's say, there can be a lot of disambiguity while classification if we just learn how a logistic regression or a decision tree works. So there, if we try to use some kind of a disambiguation to understand the more of a context and then try to go for a classification. So I wanted to understand the practicality. Does this help us a lot, or is it time effective, in the sense, does it increase the time complexity of the model if we try to include everything in that? Or just, can this be used in our classification models or classification techniques to improve the score, the prediction scores and stuff like that? Will it be effective in general?
Okay, so like even I don't have 100% clarity on the exact thing you're asking, but what I can suggest is that, so this is like whatever you are calculating from here is from the word net, right? So
Yeah.
word net is like a knowledge base. So it is like
Mhm.
a knowledge base which has been constructed in some manner. So that is like
Mhm.
a dictionary of knowledge, you can think, which gives
Yeah.
you an idea about what sense words have and which are similar and all that. Okay.
Mhm.
So usually in machine learning problems, what we have is that like there are, earlier there used to be a focus on knowledge base kind of approaches, because
Mhm.
knowledge base can give you features, you can derive
Mhm.
features from a knowledge base, right?
Yeah.
So you can derive some kind of features like which sense of the word it is, or
Mhm.
like, yeah, like we have to maybe think about that. That
Mhm.
is a part of the
Mhm.
engineering aspect of the
Yeah.
problem.
Yeah.
but
Yeah.
but what you can use wordnet to do is you can use wordnet to generate features for every word.
Mhm.
Now, what
Okay.
those features exactly will be is something you will have to define. But you can
Mhm.
use WordNet to generate features, and then you can combine those features with whatever you are doing. Like,
Yeah.
however, you are constructing features, just like from the plain text, you are constructing features, right? So,
Yeah. Yeah.
you can add these WordNet derived features along with that, and you
Mhm.
can maybe see some improvement. Like,
Ah.
I'm
Okay.
saying it on a bit abstract scale,
Yes.
like,
Yes. Got it. Got it.
but for
Yeah.
implementation purpose you will have to look a bit more into it, but this is the
Mhm.
general idea. You can
Okay.
use wordnet to get some features, and you
Mhm.
get some features from the text itself, and you combine
Yeah.
them for classification.
So basically, these ideas of whatever we have been learning from last 2 weeks, more about semantics and all these things. So we can use them to extract features from the text that we want to classify, and maybe use them together in an algorithm and help
Yes,
see how the model learns using those features
yes,
and how does
yes.
it help us.
Yes, so
Okay.
like word embeddings, which was there in the previous chapter. So
Mm-hmm.
word embeddings is like, uh, so the main idea is that in the like in the old days, people used to design the features themselves by hand. Okay,
Mm-hmm.
so you decide a list of 10 features, and
Yeah.
then every example or every word, however you put it, can then be
Mm.
described as a feature vector, like a 10
Yeah.
dimensional feature vector, right? And
Yeah.
they can have different values.
Yeah.
Now that idea was extrapolated to the fact that what if instead of designing the features, we design a model that can learn the features themselves, or it can
Mm.
decide what features are important.
Yeah.
So that concept comes in when we are training things like Siba or skipgram models. Okay.
Yes. Yes.
So, for example, for Sibao, you are trying to predict a word given its context. And
Yeah.
every word has started off with an initial embedding, like say 100 dimensional embeddings. So, those are
Hmm.
like 100 features. We
Yeah.
don't know what they correspond to exactly.
Hmm.
But we don't
Yes.
need to know. We just know that there are 100 certain features which the model has chosen. And the idea of the model is to generate features as accurately to get better performance. Like,
Hmm.
that is where the entire deep learning concept comes in, that
So in
we,
that case, we will have to train that for our corpus domain that we are
yes,
in that
yes,
case. So that, it cannot be used out of the book in most of the cases, right? I mean, so
no,
we'll have to for our domain, we'll have to train it
yes,
with our corpus. Okay,
yes.
yeah, fair enough, fair enough. And Shauna, there was few issues with regards to some of the assignment questions that were there from last, I think, assignments week 6. I have been posting it on the forum, but I'm not getting any response and stuff. There were two questions that are absolute. One of them is was absolutely incorrect. I am very very positive about it,
Hmm.
but and that has not been corrected. And there was another question which again from my point of view, I have done two, three, four times. It is again not coming out as what the answers have been given. I have the solutions with me. I have shared it
This is
with one
about
of the, yeah.
this year's assignments, right?
This year's, yeah. It was the reason that I'm putting it here is it's not about the marks, but I just wanted to know whether the way I'm approaching or the solution that we are getting is that a correct or not. So I have the PDF format with me. I have also shared with one of the TAs I mean, Purunjay, I guess he takes at 7 to 8, between 7 to 8, he takes a session,
Hmm.
right? So I've shared with him as well. He told me that he'll take a look at it and maybe come back, but he hasn't come back with me. So can you help? Maybe I can share that solutions to with you. Can you just have a look at that and help me to understand whether I am wrong, or is there
Yes,
something wrong in the solutions that the team has provided?
so you, what you can do is that you send me a mail then of the solution they provided, and also like the solution you worked out. Okay,
So the solution, they have only given the answers, right, in the assignment. So they have not given any solutions, how they have come
okay,
to their answers,
okay,
right? So
okay.
I have the complete solution that I have gone to.
Yes, then you send
Yeah.
me the question along with the solution you have worked out. Okay,
Yeah, sure,
and
sure. Where can
I'll,
I send you? Do you have an email ID or something I can share this with you? Yeah.
yes. This is my email ID. You mail me the question along with the solution you worked out,
Yeah, sure, sure,
and
sure.
I'll check
I'll
whether it's okay.
I'll mail both of them to you. If I just mention the question number from the assignment, that should be okay.
It's better if you give me the question also.
Okay, okay. Because we cannot copy it. It's an email, so copying is a difficult. So I have to type it out the whole thing.
Okay.
So
So
there are a lot of
okay,
things in the
okay. Then
question. Yeah.
mention to me the week number and the question number. Okay.
Yeah, sure. Assignment number and the question number for and the week number as well. I'll mention all of
Yes.
them and
Yes.
share my PDF with you. Yeah.
Okay.
Okay. Thank you so much, Sonak. Yeah. Thank you.
Okay.
Yeah.
All right. So yeah, anybody else has any other doubts?
Can we maybe is the course also planning to have some hands-on sessions as part of this? I mean, you have provided some hands-on session right now. Going forward, can we expect more of this kind of a hands-on? That would be more
That
effective and more helpful to us.
your course TS will be able to tell, because if there are such sessions, they will be taking those, so they will be able to tell this. So
Okay.
we conduct these classes independent of what is going on in this year's session. Okay, kind of, you can think. So we are not connected as you might think. So it's better you ask it to them.
Okay. No problem.
All right. Uh, So I guess there are no doubts as such. Okay then. We'll end today here itself, and I'll meet you next week.
Yeah. Thank you so much, Sonak. Yeah. Bye bye.
Yeah, yeah. Thanks everyone.